students. Today we have to discuss model 2 renewable type of energy sources. It is already discussed in model number 1 what are the different types of energy resources. So advantages, disadvantages we have already observed. So renewable energy sources plays a very important role fulfilling the demand of electricity in nationwide as well as in global. But these resources are having some limitations, but we want to go for use of renewable energy sources. Hence, because after some time this fossil fuel generation is going to end. Hence the research mainly focus on the use of different types of energy resources. The wind energy is a non-conventional energy source and it is also referred as renewable energy source because it is available in natural. It is also referred as environment friendly because it doesn't pollute any environmental condition as such, like that how the petroleum products and thermal power plants pollutes the air and environment. The wind is generally referred as the motion of air shed, or air shed in motion. The kinetic energy of wind can easily converted into electrical energy. What are the different sources of wind? There are two types of winds. One we can call local wind, another we can call planetary wind. So the local wind are caused due to unequal heating and cooling of the ground surfaces or water surfaces, ocean, lake during the day and night, which creates the local winds. The planetary winds are such which are totally due to the rotation of Earth around its polar axis and unequal temperature between polar and equatorial regions. What is the amount of power developed, or what is the factors? What are the factors depends upon wind. So power in wind can be calculated by half rho a v cube. These are all factors depends upon directly proportional, where A is the area of rotor, it is in meter square. So again this area of rotor directly depends upon length of the rotor blade, because A equal to pi d square by 4, where d is the diameter of this blade. So again, as the length of diameter increases, area of rotor increases in that manner. So V is the wind speed, in meters per second, then rho density of wind in kg per meter cube. All factors are directly proportional to wind power. Hence we can't change density of wind, we can't change wind speed, only the changeable factor is area of rotor. So the design of wind power plant mainly depends upon design of area of rotor. Area of rotor again depends upon selection of length of the rotor blade. So how much length we can take or how much area we can increase, that is increases the wind power, but it is limited by certain conditions, certain limitations. Okay. Then what are the wind characteristics? In hill and coastal areas, the average wind speed is higher than on the land. Hence, it is more suitable. Now we are seeing wind power plants are located in hill and coastal areas. That is the character. The wind tends to blow more constantly and with higher greater strength over the surface of water, because at the water surface the drag effect is less. So Later on we are having again two types of wind turbines on the coastal area of the coastal area. Hence, this factor is also encourages why not wind generation on surface of coastals. In sea level also huge amount of wind speed is available with constant strength. Hence, we have to erect the wind power plants in the sea surface also. Then wind speed increases with increase in height, because as the height increases, the dragging effect of earth reduces. That's why the wind speed should be located, the wind turbine are located at certain height from the ground level. So there are two types of wind turbines depending upon axis of turbine rotation. So one horizontal axis type wind turbine, number two vertical axis type wind turbine. This is one wind power plant. Wind turbine is arranged in axis, horizontal types wind turbine. Now you can see there, this is a typical wind power plant. So first you see the rotor blades. Rotor blades are fixed to the hub. Then wind directly enters perpendicular to the rotor blades. So how much length of rotor blade? It increases rotor area. This wind turbine is coupled to gearbox. Wind turbine shaft is coupled to gearbox. This gearbox is coupled to generator. Later on, controller is also available in this wind generation assembly. This is also referred as Nestle. It is fixed. Whole assembly is fixed with supporting structure. Sometimes it is also called towers. How the transmission lines are fixed. Getting the idea? All arrangement of this wind generation plant fixed at certain height on the supporting structure as shown in figure. So roughly wind turbine, what is the function of wind turbine? It converts the kinetic energy of wind to rotational energy. Number one, it converts kinetic energy of wind to rotational energy. This rotational energy is giving input to gearbox. Gearbox has a such arrangement, it can change the speed. Which is required for generator. It may be ratio, depending upon gear ratio, mechanical arrangement, we can change the speed of rotation. That rotation is depends upon the rotation of generator. Getting the idea? Rotation of generator. This gearbox output is given to the generator. Generator is one electrical machine. It converts the mechanical energy of gearbox to the electrical energy. In this manner, kinetic energy of wind is converting into electrical energy. Now you can see this is one of the commonly used turbine. In this type of turbine, axis of rotation is horizontal, that is parallel to ground as shown in figure. The rotors are placed or the rotors are arranged in the direction of normal to wind. When the wind passes over the surface of the rotor blade, it will create some low pressure area as compared to drag device. The difference of pressure along the wind blade, along the rotor blade, creates aerodynamic lift, aerodynamic effect. Hence, it starts the rotating. It starts the rotating. This wind turbine may be drift type, or it may be of drag type, or lift device. Hence, almost lift device type is more useful for the maximum output production for a given wind speed. This rotational energy is given to gearbox. Then gearbox boost the speed. This boost of speed depends upon generator design. Then finally it generates the voltage. The generated voltage from the generator given to transformer. Then transformer output, it increases the voltage level. It increases the voltage level. Finally, this generated voltage may be given to grid or distribution network as shown in figure. So, vertical axis type of wind turbine, another type. This is the history of wind started from vertical axis, because before going to the wind generation, the farmers, they are used this method for different applications as their requirements. Many applications that went. So vertical axis wind turbine is small power generating unit. So this axis is vertical. The axis of the rotation is vertical as shown in figure. At the top, aerofoil type of blades are fixed. These blades moves with parallel to the direction of wind. Again, it is having a advantage. It should not require to place in the direction of wind. It should not require in the direction of wind speed, but should not direction of particular direction of wind. Earlier horizontal type whole nacelle should be rotating arrangement in the direction of wind. Here there is no such arrangement is required. Wind directly comes and rotates the aerofoil blades, then vertical axis rotates. So all generating units, generators and gearbox, all are placed at bottom arrangement, that is near to earth or on the earth. Hence this problem is also overcome. Then guides are used to support the wind generation power plant, and some supporting structure is also required. Hence a small amount of power can be generated. This already I explained earlier. The vertical axis wind turbine is axis is vertical to the ground surface, that already we have seen. Now see that this is one of the block diagram. Wind energy conversion system, WECS. It is very important to remember. Or what are the components exist inside the wind generation plant. So you can go through the block diagram. First block, aero turbine or wind turbine. You can call wind turbine. Wind turbine input is wind. Whenever wind hits the turbine with aerodynamic effect, it starts rotating. That rotational energy is given input to gearbox. Gearbox, with the certain ratio of mechanical arrangements, it increases the speed, it changes the rotational energy. This rotational energy or speed is coupled to the generator shaft. This output of gearbox through the coupling is given to generator. Then generator, as the wind turbine rotates, this rotating part of the generator rotates. As per the Faraday's laws, the EMF can be generated. that generated controls either shaft speed, temperature, uh, the involvement of sensor arrangements or some SCADA system. We have to control the operation of generator, the operation of gearbox, and what is the wind speed. All should be given some controller unit. It controls, it takes the data, it controls, because if more wind is available, the system should be off. If less wind is available, then also system should be off, because wind generation will operate for particular range of wind speed only. Lower speed, again it remains cut off. Very high dangerous speed, at that time also there is a damage may cause to the whole wind unit. Hence the generation remains off by using some controller instructions. Hence you practice these all things. Thank you, sirs.